Hey everyone, welcome to AppleKnows Channel. I'm Apple, and today, I'm going to tell you some chemical truths that sound absolutely insane, but every single one of them is real. So, sit tight, because after hearing this, you might start questioning reality itself. Let's start with this: the very air you're breathing right now is mostly nitrogen. About 78%. Oxygen? Only around 21%. But here's the twist: if oxygen were even a little higher, say around 25%, your campfires, candles, and even wood furniture could burst into flames way too easily. Forest fires would be unstoppable. But if it were lower, you'd suffocate. Nature fine-tuned this ratio perfectly: a tiny shift, and life as we know it would end. And water, the most innocent-looking liquid, is one of the strangest chemical substances in the universe. It expands when it freezes, unlike almost every other liquid. That's why ice floats, keeping fish alive under frozen lakes. If water behaved like a normal liquid, the oceans would freeze solid from the bottom up every winter, killing everything. Water literally breaks the rules of chemistry, and saves the planet doing it. Now, let's talk about something that sounds straight out of science fiction. Did you know that glass isn't actually a solid? It's a supercooled liquid. It flows so slowly that you can't see it move, but old cathedral windows are thicker at the bottom because the glass has been creeping down for centuries. It's a liquid pretending to be a solid, and we live behind millions of transparent lies every day. Here's another one: diamonds, those glittering symbols of luxury, are just carbon. The same element as charcoal. The only difference is how the atoms are arranged. Under extreme pressure deep in the earth, carbon atoms lock into a crystal structure so perfect that it can cut through anything. But chemically, if you burned a diamond, you'd get nothing but carbon dioxide, just like burning coal. The line between priceless and worthless is just chemistry's sense of humor. Now, let's go darker. There's a chemical called dimethylmercury, one of the deadliest substances on the planet. Just a few drops on your skin can kill you, even through latex gloves. It moves silently through layers of protection, enters your bloodstream, and begins destroying your nervous system. Scientists handling it wear special gear, and still, accidents have happened. In 1996, a researcher named Karen Wetterhahn spilled a tiny amount on her glove. Months later, she started showing symptoms. She died slowly, from something smaller than a raindrop. Chemistry doesn't forgive carelessness. And then there's fluorine. The most reactive element known. It attacks glass, steel, water, even humans, with terrifying aggression. When scientists first isolated fluorine, they almost all died trying. It reacts so violently that it can set fire to ice. Imagine something that turns frozen water into a blazing inferno. That's fluorine, chemistry's version of pure rage in element form. But not all chemistry is death and destruction. Some is just mind-blowing beauty. Like how every color in fireworks is pure chemistry: strontium gives red, copper gives blue, sodium gives yellow, barium gives green. Each explosion is atoms releasing light as they calm down after being excited by heat. Every spark you see is an electron falling home, painting the sky with its last bit of energy. And then there's the smell of rain, that earthy, nostalgic scent we all love. It's caused by a compound called geosmin, produced by soil bacteria. When raindrops hit the ground, they trap air bubbles filled with geosmin that burst and send that smell into the air. You're literally inhaling the signature of living microbes that have existed for millions of years before humans. Oh, and let's not forget the banana. Bananas are slightly radioactive. So are you, by the way. They contain potassium-40, a naturally occurring isotope that emits radiation. Don't worry, you'd have to eat about 10 million bananas at once to get a fatal dose, but technically, every time you bite into one, you're tasting atomic instability in motion. And the most shocking fact? Every atom in your body, the carbon in your muscles, the calcium in your bones, the iron in your blood, was forged in the core of a dying star. You're literally made of stardust. When stars explode in supernovas, they scatter the elements that later form planets, oceans, and people. So next time you look up at the night sky, remember, you're not looking at strangers. You're looking at your own origin story written in fire. If you thought those facts were wild, buckle up, because the deeper you go into chemistry, the stranger reality gets. Let's start with something you see every day but never think about: color. Did you know that the color of the sky is literally caused by molecules scattering sunlight? It's called Rayleigh scattering. The blue wavelengths of light are shorter, so they get bounced around by air molecules more than red or yellow. But here's the twist: if Earth had a different atmosphere, say, more carbon dioxide like Mars, the sky wouldn't be blue at all. It would be butterscotch orange. The color of our sky is just the atmosphere's chemistry painted across infinity. Now here's something that sounds impossible: metal can float on water. Sodium and potassium do it naturally. They're so light and reactive that when they touch water, they explode. Not metaphorically, explode. The reaction is so fast that hydrogen gas bursts into flames instantly. There's even footage of a piece of cesium, another metal, thrown into water, and it detonates like a small bomb. These metals are part of the same family on the periodic table, known as alkali metals, and they all share the same explosive personality. Speaking of personality, let's talk about one element that might surprise you: oxygen. We think it gives life, but oxygen is actually a slow poison. It causes things to rust, metal to corrode, and cells to age. Every breath you take slowly damages your DNA. The only reason we survive is because evolution taught our bodies to handle it, barely. If oxygen were just a little more concentrated, we'd age twice as fast. The very thing that keeps us alive is also what's killing us, molecule by molecule. Now picture this: you pour hydrogen peroxide on a cut, it bubbles and fizzes. That reaction is your blood fighting back. The enzyme catalase in your body instantly breaks down hydrogen peroxide into water and oxygen gas. Those bubbles you see are tiny bursts of oxygen escaping. You're literally watching your cells perform chemistry at the speed of life. Let's get weird. There's a metal called gallium that melts in your hand. Its melting point is just above room temperature, around 29.7 degrees Celsius. You can hold a solid piece of it, and it'll turn into liquid metal between your fingers like something out of a sci-fi movie. And the best part? When it cools, it solidifies again. It's harmless, mesmerizing, and one of the few elements that seems to break every expectation you have of what metal should be. And have you ever wondered what's inside the sun? It's not fire, it's a nuclear reaction driven by hydrogen fusion. But the chemistry doesn't stop there. If you somehow scooped out a spoonful of the sun's core, it would weigh as much as an entire mountain on Earth. That's how densely packed hydrogen atoms become when gravity compresses them to the edge of existence. Here's a chilling one: as scientists once discovered a chemical compound that exists in space but not on Earth. It's called diatomic helium, two helium atoms bonded together. Normally, helium doesn't form bonds, it's too stable, too noble. But in the crushing pressure of white dwarf stars, even helium gives in. The chemistry of the cosmos is so extreme that it creates materials we can't even imagine existing here. And speaking of the unimaginable, let's talk about the smell of almonds. That sweet, pleasant aroma? It's from benzaldehyde. But in bitter almonds, you'll also find amygdalin, which breaks down into hydrogen cyanide, a deadly poison. The difference between delightful and deadly can be a single molecule. Chemistry doesn't care about morality, it's pure cause and effect. Now here's one that might change how you see your body forever: when you touch something, you're not actually touching it. The electrons in your skin repel the electrons in the surface you're reaching for. On an atomic level, there's always a microscopic gap: you never truly make contact. Every handshake, every hug, every sensation of pressure is just electromagnetic forces resisting one another. Touch is an illusion built by chemistry and physics conspiring together. And just when you think that's the limit, you realize you're breathing ancient air. Every lungful of oxygen you take contains atoms that passed through the bodies of dinosaurs, through volcanoes, through kings and queens long dead. The same atoms just keep cycling through Earth's biosphere endlessly. Chemistry doesn't destroy, it rearranges. You are literally recycling history with every breath. The next facts I'm about to tell you will twist the way you see the world and yourself through the eyes of chemistry. Let's start with something invisible but powerful: smell. Every scent you've ever experienced is a molecule floating in the air, finding its way to the receptors in your nose. But here's the shocker: when you smell something, you're actually absorbing tiny bits of it into your body. The aroma of coffee? That's caffeine molecules landing on your nasal membranes. The scent of gasoline, roses, or rain? Those are actual particles of those substances entering your brain through chemical signals. You never just smell chemistry, you inhale it. Now, think about salt. Ordinary table salt, sodium chloride, is made from two deadly elements. Sodium, a metal that explodes in water, and chlorine, a green, poisonous gas once used as a weapon. Mix them together in perfect balance, and they form the single most essential compound for human life. Chemistry can take two killers and make something vital from them. Balance is everything. Let's move to the world beneath your feet, soil. Every handful of dirt is alive with chemical reactions. Bacteria release acids that dissolve rocks, creating nutrients. Fungi trade those nutrients with plant roots through microscopic networks, literally forming the planet's underground internet, called the mycorrhizal network. Every forest is connected by chemistry. Trees talk to each other through signals passed via shared chemical threads. When one tree is attacked by insects, it warns the others by sending molecules through the soil, triggering chemical defenses in neighboring trees. That's not magic, that's molecular communication. Here's one that bends your sense of reality. There's a chemical element called bismuth, and it's so stable that it was once thought to never decay. Then scientists discovered it actually does, just unimaginably slowly. Its half-life is longer than the age of the universe, more than 1 billion times older, meaning the bismuth in your hands today will still be here when the stars you see tonight are gone. It's a metal that defies time itself. And let's talk about taste. Your tongue isn't just detecting flavors, it's performing chemical analysis. Sweet, sour, salty, bitter, umami each corresponds to a specific molecular shape or reaction. Your body instantly decodes those signals and translates them into pleasure or warning. Bitter often means toxic, sour warns of spoilage, and sweetness tells you energy is available. Evolution turned chemistry into emotion, and that's why food can make us feel happiness, disgust, or nostalgia. Ever heard of the element osmium? It's the densest naturally occurring substance on Earth. A cube of osmium the size of a sugar cube weighs almost half a kilogram. It's so heavy that if you dropped it into your palm, you'd feel gravity differently. And yet, if you grind it into powder and inhale it, it becomes deadly. Its oxide form destroys lung tissue. The same element that feels like a piece of alien metal can also become a toxic mist. Chemistry loves contrast. Now, brace for something cosmic. The heaviest elements on the periodic table don't exist naturally on Earth. They're made in laboratories by slamming atoms together at nearly the speed of light. These man-made atoms live for fractions of a second before breaking apart. They exist just long enough to prove they can exist. Humans, using chemistry, literally create matter that the universe never made. We are rewriting nature's periodic script one unstable element at a time. And let's not forget the strange truth about your body's chemistry. Every cell in you replaces itself over time. Your stomach lining regenerates every few days, your skin every few weeks, your bones every decade. The you that existed 10 years ago is gone, atom by atom, replaced by new matter. You feel continuous, but chemically, you're a completely different person. Memory, not molecules, keeps you the same. And here's one that might blow your mind completely. If you took all the empty space out of the atoms that make up every human on Earth, the entire population could fit into a single sugar cube. Matter is almost entirely emptiness. You, me, the screen you're looking at, it's all energy patterns, not solid objects. Chemistry reveals that the solid world you see isn't solid at all. You've heard strange facts before, but what's coming next will make you question the boundaries of life, matter, and even death itself. Let's start with the weirdest truth about your existence. Your body glows in the dark. You can't see it, but it's real. Humans naturally emit tiny amounts of visible light, about 1,000 times weaker than your eyes can detect. This glow peaks in the afternoon and fades at night, following your metabolism. It's not spiritual, it's chemistry. Every breath, every heartbeat, every cell reaction releases photons. You're literally shining with life, just too dim to notice. Speaking of glowing, there's a chemical called luminol. You've seen it in crime shows. Spray it, and blood glows blue in the dark. But the magic isn't magic, it's oxidation. Iron from hemoglobin triggers a reaction that excites electrons in the luminol molecules. When they fall back to their normal state, they release energy as blue light. Chemistry remembers what you try to erase. And while we're on the topic of light, did you know that sunlight is mostly invisible? Only a tiny portion of the electromagnetic spectrum is visible to our eyes. The rest, infrared, ultraviolet, gamma, radio, is all there, flooding through you right now. You are constantly being hit by waves of energy that your body can't see but definitely feels. Chemistry translates those invisible interactions into warmth, burns, and sometimes, mutations. Let's get a bit darker. There's a substance called polonium-210, so radioactive that just 1 gram of it can kill millions. It releases alpha particles that rip through cells like tiny bullets. The strangest part? It was discovered by Marie Curie, the same woman who gave the world hope through science, and it's also what eventually killed her. The price of discovery was written in radiation. Now, let's flip to something almost poetic. Snowflakes, those delicate frozen crystals, are nature's geometry in motion. Each one forms as water molecules lock into hexagonal symmetry around a dust particle. But here's the fact, no two snowflakes are identical because they form under slightly different temperatures and humidity. Every snowflake is a frozen diary of the air it fell through. Chemistry doesn't repeat, it composes variations of beauty. And if you think chemistry is silent, listen closer. Your nerves don't use electricity like wires do, they use chemistry. Each nerve impulse is an electrochemical wave of sodium and potassium ions swapping places along your neurons. Every thought, every emotion, every memory is born from atoms trading positions at lightning speed. You're not powered by wires, you're powered by chemical rhythm. Here's one that sounds like pure madness. There's a metal that bursts into flames when you expose it to air. It's called white phosphorus. It glows in the dark and ignites spontaneously at room temperature. It's so dangerous that it must be stored underwater. Yet it's also essential in DNA and ATP, the molecule that powers every cell in your body. The same element that burns everything it touches also fuels the spark of life. And while we're talking about contradictions, let's discuss liquid oxygen. It's pale blue, extremely cold, and magnetic. Yes, magnetic. Pour it near a magnet and you'll watch it crawl toward it like it's alive. Oxygen, the air you breathe, is paramagnetic, it's literally attracted to magnets. Chemistry hides wonders in plain sight. Now imagine this, there's a compound called tetrahydrocannabinol, THC, that mimics your brain's natural endocannabinoids, the chemicals responsible for pleasure and relaxation. Nature didn't invent cannabis to get you high, your own brain already produces a version of the same molecule. The plant just happens to make an identical key to your brain's lock. And here's something you won't believe until you hear it twice. If you compressed all the atoms in a single human being so that their nuclei touched, that person would fit inside a speck of dust, but they would still weigh the same. That's the principle behind neutron stars, collapsed remnants of massive suns. A teaspoon of neutron star matter would weigh as much as Mount Everest. Chemistry, pushed to its limit, becomes gravity's masterpiece. Let's not forget the strangest chemical experiment nature ever pulled off, life itself. Billions of years ago, Earth's oceans were full of simple molecules. Then lightning struck, volcanoes erupted, sunlight poured down, and atoms rearranged into something that could copy itself. From lifeless chemicals, self-awareness was born. You are the product of molecules learning how to remember. Let's begin with something that seems harmless, water. You know it freezes at 0 degrees Celsius and boils at 100 degrees Celsius, right? But that's only true here, at normal atmospheric pressure. Change the pressure, and the rules collapse. On Mount Everest, water boils at about 70 degrees Celsius, too cold to make decent tea. But deep in the ocean, under tons of pressure, it can stay liquid at over 400 degrees Celsius. Superheated water exists near volcanic vents, hotter than fire, yet it doesn't boil. The same molecule that quenches flames can, under the right conditions, outlive them. Now imagine this: glass can flow, water can burn, and even rocks can evaporate. On planets like Mercury or the Moon, where temperatures soar above 400 degrees Celsius, rocks literally sublimate, turning into vapor over millions of years. Chemistry doesn't care what's solid, it only obeys the dance of energy. Speaking of rocks, there's one metal that behaves like a liquid and a solid at the same time: mercury. It's so dense that iron floats on it, and it's one of the few elements that's liquid at room temperature. But here's the haunting twist: mercury eats gold. If you drop gold into liquid mercury, it dissolves into an alloy called an amalgam. Ancient alchemists used this reaction, thinking they were close to creating eternal life. What they didn't know was that mercury slowly poisons the brain. Their quest for immortality ended in madness through chemistry. Now let's talk about color again, but in a way you've never heard. The color of objects isn't in the object, it's in the light reflected by it. A red apple, for example, absorbs every color of light except red. It reflects the one wavelength it refuses to keep. That means the color of everything you see is actually the color it rejects. The world you perceive is made of what matter pushes away. And you're glowing too. Literally radioactive. Every second, about 7,000 atoms in your body decay. Potassium-40, carbon-14 natural isotopes inside you quietly breaking apart, releasing energy. You are not stable. You're a living reactor, powered by decay. But don't worry, without that radiation, life's chemistry would stop evolving. Mutation, the engine of evolution, depends on it. Life survives by constantly changing, and chemistry is the force that keeps it unstable enough to grow. Now, here's one that will make your imagination ache. There's a substance called aerogel, often called frozen smoke. It's 99.8% empty space, yet it can support thousands of times its own weight. NASA used it to catch particles from comets without destroying them. You can hold it in your hand, it looks like solid air, and feel like you're touching nothing at all. The lightest solid ever made by humans is almost pure nothingness, yet it's strong enough to stop a bullet. And here's something truly chilling: on Venus, it rains sulfuric acid. On Neptune, it rains diamonds. Deep inside that frozen blue world, carbon atoms are compressed so intensely that they crystallize and fall like diamond hail. Somewhere out there, entire storms of gemstones are crashing through alien skies. Chemistry is the universe sculpting art from pressure. But you don't have to leave Earth for something astonishing. Take lightning, it's not just electricity. Every lightning bolt triggers chemical reactions in the air, turning nitrogen and oxygen into nitrates, which later fall to the ground with rain. That's right, lightning fertilizes the planet. Every thunderstorm helps plants grow. Nature uses destruction to create life. Now let's go microscopic. Your DNA, the blueprint of your being, is made of only 4 chemical letters, A, T, C, and G, yet with just those 4, arranged in different sequences, chemistry built everything from bacteria to humans. 4 molecules, endless possibilities. And here's the unbelievable part: if you stretched out all the DNA in your body, it would reach from the Earth to the Sun and back over 600 times. All of that inside you, folded, coded, and working flawlessly every second. And now something that sounds like fiction but isn't: scientists have created a molecule that can remember. It's called a molecular switch. It changes shape when hit with light, and stays that way until light hits it again. It's the foundation of molecular computing, chemistry that behaves like a brain. The future of memory might not be silicon, it might be molecules thinking chemically. And speaking of thinking, your emotions, your fears, your joy, they're all chemistry. Dopamine, serotonin, oxytocin, molecules that decide whether you feel love or despair. One tiny chemical imbalance, and your entire perception of life can shift. Happiness isn't abstract, it's molecular. You don't just feel emotions, you react them. And that brings us to the end of our journey through the hidden universe of chemistry. I'm Apple, and this was AppleKnows Channel. What you've just heard isn't just a collection of strange facts, it's proof that the world is far more complex, fragile, and awe-inspiring than we imagine. Every color you see, every scent you breathe, every emotion you feel, every star you look at, all of it is chemistry playing out with perfect precision. You're made of the same elements that burn in suns, the same carbon that built the first living cell, the same oxygen that carved mountains and rusted time itself. You are a chemical miracle pretending to be ordinary, and that's the greatest fact of all. So the next time you light a candle, sip water, or take a breath, remember, you're not just part of the universe is happening through you. Thanks for watching AppleKnows Channel. I'm Apple, and as always, stay curious, because chemistry never sleeps.